Today we're going to go over some equations that are just a little bit harder to solve. There's one special case that we'll talk about on this front side, and then on the back side we're just going to talk about some questions with fractions because I noticed that those are the problems we've been struggling with in class. So the front side, like I said, is going to be a new situation we haven't been exposed to yet. But then the back side is just everything we've been doing just with fractions because that's what we've been struggling with in class. So remember, to solve equations, we use the opposite operation of what is used in the problem in order to get the variable by itself. So for example, if addition is used in the problem, we use the opposite operation to solve it, which is subtraction. Okay. And then if there's subtraction in the problem, we would use the opposite operation of subtraction, which is addition. Same with multiplication and division. When there's multiplication in the problem, we would use division to solve it. Remember, we show that work of division with a fraction bar. Okay, and then when there's division in the problem, we solve it with multiplication. And remember, we use parentheses to show multiplication. Multiplication. Okay, I did spell that right. Can't really spell when I am talking. So just remember those opposite operations. So always ask yourself what's being used in the problem, and then you're going to do the opposite of that to solve it. Okay, to get that x all by itself. Now here's this new special case that we have not seen yet. Okay, we've always had like x minus 12 or x minus 9, where we would just add 12 or add 9. Okay, so in this case, we're having 12 minus x and 25 minus x, not x minus 12 or x minus 25. Okay, so it's just going to be a little bit different situation. So when we have a problem that is subtracting x, you must first add x to both sides to get it to be positive. Okay, and I'll show you what this means. Do not copy down what I'm about to write. Okay, so if we were going to solve this like we normally would, we'd want to get whatever's next to x by itself, so we'd have to subtract 12. Well, I already see an issue because we have to do 10 minus 12, and that's going to be a negative number. We have not learned how to do that yet. So that's our first issue, but let's just go with it. Okay, these 12s would cancel out, but we're still left with a minus x. Okay, and it's going to be equal to a negative 2. We don't want to know what a minus or a negative x is equal to. We want to know what a positive x is equal to. Okay, so these are all the issues that we're going to run into if we don't add that x as our first step. Okay, so now you are going to copy down what I'm writing because this is the correct way to solve it. Okay, so we always have to add x to both sides first. So we're going to add x to both sides. All we're doing is moving it over to the other side so that we have a positive x. Because a minus x plus x just cancels out. Just like when we have minus 9 and we add 9 to it, it cancels it out. Okay, so now we're going to be left on the left side with 12. Okay, on the right side now we have a 10 plus x, so we have a positive x. Okay, so we can get rid of this plus 10 in order to get x by itself. All right, so since we're adding x and 10, we do the opposite, which is subtracting, so we're going to subtract 10 from both sides. 10 minus 10 cancels out. On the right side, we're left with a positive x, which is just x. 12 minus 10 is 2, so we get x equals 2. So it's practically the exact same thing, except for our first step is adding x to both sides to make sure that we have a positive x, and we have to do it this way. Okay. All right, so number 2, let's try this. 25 minus x. First step is going to be adding x to both sides. This is going to cancel out our x on the left. 14 plus x on the right. Okay, now we cannot combine a 14 plus an x to be 14x because we cannot combine a number and a letter. Okay, those are not like terms. So we are just trying to get this x by itself, and to get the x by itself, we have to get rid of plus 14. Okay, so we're going to subtract 14. What we do to one side, we have to do to the other to keep this equation equal. 14 minus 14 cancels out. On the right side, we're left with x equals 5 minus 4 is 1, 2 minus 1 is 1 as well, so x equals 11. Okay, if you're starting to get the hang of this, try the next couple examples on your own, pause the video, and then resume them to check. If you still want to watch like maybe one more example of mine, that's fine. But it's going to be the same thing. You're just going to add x as your first step. So we're going to draw our line on our equals, add x. We want to get this x by itself, so we have to get rid of plus 42. We get rid of plus 42 by subtracting 42. We have to do it on both sides of that equal sign to keep the equation true. We get x equals, we cannot take away 2 from 0, so we have to borrow from the 8 to make it a 7. In order to make that 0 a 10. 10 minus 2 is 8. 7 minus 4 is 3. We get x equals 38. Right. When we have fractions in a problem, we're going to do it exactly the same way we would with regular numbers. Okay, it just might take an extra step to make a common denominator or to multiply or divide those fractions. Okay, in this case, our first step, we're still subtracting an x, so our first step is still just going to be to add an x. We're left with 3/4 equals 1/2 plus x. Okay. Just like before, when these were whole numbers, we wanted to get rid of plus, and then whatever's next to the x, so we want to get rid of plus 1/2. So we're going to subtract 1/2 from both sides of the equal sign to keep the equation true. 1/2 minus 1/2 cancels out. Now when we subtract or add fractions, we need a common denominator. The common denominator between 4 and 2 is going to be 4. Okay, so we're taking 3/4 and we're subtracting, and we need to get this 2 to be a 4, so we multiply it by 2, multiply the top by 2. 1/2 is equal to 2/4. So we're taking 3/4 minus 2/4. 3/4 minus 2/4, I'm just going to put a little arrow because I ran out of room. 3/4 minus 2/4 is equal to 1/4, which is equal to x. Okay. Like I said, when you have fractions, it's just a couple extra steps, but it's the same exact process. Okay. So these are all examples where you have to add an x first because we are subtracting an x and we need a positive x, not a negative x. Okay. You will have an example like that on your quiz next week. Okay. Now let's do some more examples with fractions. These are the ones that we were all getting stuck on in the practice. Okay, so first question that I say I always want you to ask yourself is, what are we doing in the problem? So what are we doing with 2/5 and x? Well, whenever we have something next to an x, it's being multiplied. We just don't write the little symbol there. Okay, so 2/5 times x. So to undo 2/5 times x, we divide both sides by 2/5. We always show division with a fraction bar. 2/5 divided by 2/5 cancels out. We get x equals. Now we're going to write it horizontally. So we're going to write 10 divided by 2/5, except for we need to make 10 a fraction. To make 10 a fraction, we put it over 1. Divide by 2/5. Now think back to our awesome video I know you guys loved, our keep, change, flip video. We kept 10 over 1 the same, changed division to multiplication, and then flipped 2/5 to 5 over 2. We get x equals 10 times 5 is 50, 1 times 2 is 2. 50 over 2 will then reduce to 25 because 50 divided by 2 is 25. Okay, so it's the same exact process as with whole numbers. It's just a little bit harder because they're fractions, but you can totally still do it. All right, this next one's a little easier. We are dividing in the problem, so if we're dividing in the problem, we do the opposite to solve it. So we're going to be multiplying. We show multiplication with parentheses, and we multiply it by whatever x is being divided by. So x is being divided by 1/2, so we're going to multiply by 1/2. Divide by 1/2, multiply by 1/2 cancels out. We get x equals 12 over 1 times 1 over 2. We're multiplying fractions, so we just multiply straight across. We get x equals 12 times 1 is 12. 1 times 2 is 2. 12 over 2 reduces to 6. All right. Adding and subtracting. We want to get rid of whatever's next to the x. So we want to get rid of a plus 1/2, and we do that by subtracting 1/2 to both sides of the equal sign. 1/2 minus 1/2 cancels out. We're left with x equals 3/4 minus 1/2. Now we're going to rewrite this with a common denominator. 1/2 out of fourths is equal to 2/4. So 3/4 minus 2/4 gives us a final answer of 1/4. All right, last example. We have x minus 3/4 equals 5. Line down our equal sign. We want to get rid of minus 3/4. The way that we undo subtraction is with addition, so we're going to add 3/4 to both sides. Minus 3/4 plus 3/4 cancels out. We get x equals 5 plus 3/4, which is just 5, and 3/4. Pretty simple. Final answer. All right, at this time, I want you to complete the next 2 problems on your own. Okay, now you need to know how to do this because this will be on your quiz. They are not, well, I guess the second one is a fraction problem, but the first one, they're just the subtracting x problems. Okay, so our first step is to add that x to both sides, and then you're just going to solve it like a normal equation. So I want you to try these 2 on your own. When you finish them, you need to get your answer checked by a teacher. Okay, and then you can move on to the practice. But you need to get these 2 correct in order to be able to move on to the practice today. Okay, I will not show you the answers in the video, so when you're done, you'll just raise your hand to see if you got the right answers.